Hello people, let's now see this question from GATE 1999. Actually, we'll be seeing two questions. First one is from 1999, it's a 2-mark question. And the other one is from GATE 2002, it's a 1-mark question. I'll first read out the statement for of the question from 1999. Arrange the following configuration of CPU in decreasing order of operating speeds. Hardwired control, vertical microprogramming, horizontal microprogramming. Okay, so you need to arrange these three. First thing is, control units are of two types, hardwired or microprogrammed. Further, microprogrammed can also be horizontal microprogramming or vertical microprogramming. Because hardwired uses only hardware to generate the control signals. So this one is the fastest. Okay. This is obviously going to be the fastest. Now let's see these two. One thing, this is hardwired control unit. This is not a softwired control unit. There's nothing like softwired. It's called microprogrammed because this is based on a program. This is only based on hardware. Now, because both of them actually use hardware, this one uses only hardware, this uses hardware as well as some software. So that software runs on top of a hardware. That's the reason why this becomes a little slower. Okay, so let's analyze which one out of these two is going to be the faster one. Okay, so both horizontal and vertical contain a set of micro instructions. What are micro instructions? The instructions that are used to carry out micro operations. I've actually explained all this in great detail in theory lectures. You please watch them. Anyways, let's just spend 1 minute. Microprogram is a program which consists of micro instructions. And this program helps in execution of one instruction, one normal instruction, not a micro instruction. Okay, anyways, let's just continue our question. Horizontal means the program will be more lengthy in horizontal direction. What do I mean by that? Okay, if you're using vertical microprogramming, your program might look like this. And if you're using horizontal microprogramming, your program could look like this. What I'm trying to say is, in vertical microprogramming, number of micro instructions are large. That means there are a lot of micro instructions within a program, but size of one micro instruction is less. Okay. But what happens in horizontal? Horizontal, the size of a micro instruction is large, but you need less micro instructions to do the same job. Now, which one is going to be the fastest one? In vertical, what happens is, because instructions are too many, you will face more fetches, more decodes, and more executes. Okay, I'm not talking about memory fetch, decode and execute, not the normal ones. These are for executing a micro instructions. This fetch happens within the CPU. I hope you know what I'm talking about. Okay, anyways, if you don't know what is all this, please watch my theory lectures. I've explained this in a great detail. Anyways, here, first thing is you are spending more time to execute instructions because number of fetches is going to be more because simply instructions are more in number. So you can conclude that horizontal is going to be faster one. Next thing is, vertical one will actually have a complex decode phase because here what you are doing is you are trying to compress data. Say you have 10 control signals in total. You need to generate 10 control signals in total. And to represent one or to actually address one of 10 items, you know 4 bits are enough. Okay, because 2 raised to the 4 is 16. That means 4 bits could represent 10 items. That means only 4 bits are enough to support 10 micro instructions or 10, rather I'll say 10 control signals. And next thing is, Now you need a decoder to decode these 4 bits. That means you actually need to know which control signal are we talking about. But what happens here? Here you reserve 1 bit for each control signals. That means actually we'll be having 10 bits here. Like this, you will have 10 bit, 1 bit to represent one control signal. Say at some particular time you need this control signal high. You will just save 1 here and all other zeros. Now what will happen is you don't need a decoder. You just directly connect this bit to the desired register, I can say register or desired device. And whenever we save 0 here, the control signal will be low. Whenever we save 1 here, control signal will be high. What's the benefit of doing this? We can generate more than 1 control signals using this pattern only. Okay, say at some time you need 2 of the control signals to be high. So you'll just save 1 there also. But in this one it's not possible because these 4 bits at any time can represent only 1 out of the 16 possibilities. That means you can say 1 out of the 10 possibilities. Okay. So here less number of instructions are going to be needed because you are compressing data this way. Okay. Here more number of instructions will be needed because you are compressing data this way. Anyways, this one is going to be faster because less number of fetches will be encountered. Because obviously less instructions means less fetches. Next thing is you don't need to decode anything. Decode phase can be skipped here because it's already decoded. What will you decode further? You just connect these to the control signals. Okay, so your answer here is fastest one is hardwired, then we have horizontal, then we have vertical. Yeah, so this is the order. Fastest and slowest. Vertical is the slowest one. Okay, I think you can see which option it is. Now let's see the question from 2002 exam. It's a 1 mark question. Sorry, not from 2002, it's 2004 exam. Just a second. Horizontal microprogramming, then you have 4 options. Does not require use of signal decoders. B option is results in larger sized microinstructions than vertical programming. C option is uses 1 bit for each control signal. And D is all of the above. Now you can easily guess that it's all of the above because we have discussed it does not require any decoders. Simply because here you have compressed data. You have represented 10 different control signals using only 4 bits. So you need to decode this information. But here 1 bit is present for 1 control signal. No. So no decoders are required here. Option A is correct. Option B results in larger sized microinstructions than vertical. Yeah, size of a microinstruction has obviously increased when we are using horizontal. Here we have 10, here we have only 4. Okay, so option B is also true. Option C says uses 1 bit for each control signal. Yeah, obviously true. So your answer is all of the above. Okay. Thank you very much for watching this video.